Today we're looking at this webinar, Wireless Connectivity, Enabling the Next Industrial Revolution. It's from the Alpert research team. And it really dives into the convergence of wireless communication with Industry 4.0 and 5.0. What are the key challenges organizations typically face when trying to adopt these advanced wireless technologies? It surely can't be all smooth sailing.
You're absolutely right. It's definitely not plug and play. While the potential benefits are immense, there are significant barriers and challenges that organizations must proactively understand and navigate to successfully implement and scale these industrial wireless solutions. The sheer proliferation of connected devices, sensors, actuators, machines, mobile robots, AR headsets in Industry 4.0 and 5.0 vastly expands the potential attack surface. So how do organizations address these formidable security challenges? There's no single silver bullet, but effective resolutions typically involve implementing comprehensive, multi-layered security frameworks. This often includes leveraging AI-based anomaly detection systems. Using lightweight encryption protocols suitable for resource-constrained IoT devices is crucial. Organizations are also starting to explore and plan for quantum-resistant cryptographic algorithms to prepare for the future threat of quantum computers potentially breaking current encryption standards. Furthermore, as we discussed, deploying private 5G networks offers an inherent security advantage by physically or logically segregating sensitive industrial data traffic from public networks. This is the challenge of compatibility across protocols and legacy systems. Manufacturing facilities are rarely built from scratch with all new equipment. They typically operate with a highly heterogeneous mix of machinery and control systems. Integrating these disparate systems with their different communication standards and data formats with new wireless technologies like 5G, Wi-Fi 67, or LPWANs is non-trivial. It's definitely not about finding one best wireless technology that magically solves everything for every piece of equipment. Instead, a strategic approach requires careful planning, understanding the specific needs of different applications, and often selecting and integrating multiple wireless technologies appropriately. The solution really lies in architecting a carefully planned heterogeneous network, leveraging the strengths of each chosen technology standard while implementing robust bridging and translation mechanisms. Often this is done through a phased modernization approach, tackling specific areas or applications step by step rather than attempting a massive, disruptive rip and replace. As we established, many critical industrial applications, especially those involving real-time closed-loop control, coordinated motion systems, or safety-critical functions, demand extremely low and, crucially, bounded latency, often consistently at the millisecond or even microsecond level. They also require incredibly high reliability. Wireless channel conditions themselves are inherently dynamic and challenging. Signals can be affected by movement of machines or people, interference from other radio sources, signal reflections, multipath fading, or physical obstructions, all of which can impact communication reliability and also affect the precision of time synchronization mechanisms. The integration of TSN principles directly into the MFK medium access control and PHY, physical layers of wireless standards like 5G, resulting in 5G TSN and Wi-Fi 7, is paramount. It focuses on developing advanced scheduling techniques to meticulously manage network resources and guarantee specific time slots or transmission opportunities for critical, time-sensitive traffic, ensuring it meets its strict per-flow latency and bandwidth requirements regardless of other, less critical traffic on the network. Ensuring energy efficiency for massive deployments. In large-scale industrial IoT deployments, particularly those using wireless sensor networks, WSNs or LPWANs for monitoring, however, replacing batteries frequently across potentially thousands or even millions of devices becomes incredibly costly, time-consuming, disruptive to operations, and often impractical or even unsafe. Optimizing energy consumption across these vast, dense networks is absolutely essential, not just for reducing operational expenses, but also for achieving long-term sustainability goals. The development and adoption of inherently ultra-low power wireless technologies, like the LPWANs we discussed, NB-IoT, LoRaWAN, Sigfox, are critical. These are specifically designed from the ground up to minimize energy consumption. Secondly, emerging wireless power harvesting. These technologies aim to capture energy from ambient sources in the environment like stray radio frequency, RF signals, indoor lighting, solar cells, thermal gradients, or even mechanical vibrations to trickle charge the device's battery or potentially power it directly, further extending operational life or even eliminating the need for battery replacements entirely in some scenarios.
We've certainly journeyed through a fascinating and complex landscape today. We've gone from the foundational shifts of Industry 4.0 and the human-centric, sustainable goals of Industry 5.0, right through to the intricate web of wireless technologies 5G, 6G, Wi-Fi, LPWANs, and more that are making it all possible. And importantly, we've also faced the very real challenges: security, compatibility, determinism, energy, spectrum, that demand our ingenuity and strategic thinking.
It's a dynamic and rapidly evolving field. To perhaps summarize this transformative journey and borrowing from the conclusion of the Alpert research team's work that guided our discussion, Industry 5.0 is no longer a futuristic vision. It is an evolving reality, and wireless communication is the enabler at its core. Organizations that proactively embrace wireless innovation will unlock smarter production systems, resilient supply chains, and sustainable human-centric value creation. As the industrial landscape continues its shift toward autonomous, intelligent, and adaptive ecosystems, the speed and sophistication with which enterprises adopt and integrate wireless technologies will determine their long-term competitiveness. So, Industry 5.0 isn't just some far-off idea anymore. It's actually happening now, it's evolving, and wireless communication is right there at the heart of it, enabling it all. Organizations that really lean into wireless innovation, they're the ones who will unlock smarter production, more resilient supply chains, and ultimately create value that's sustainable and human-centric. As this whole industrial landscape keeps shifting towards being more autonomous, more intelligent, more adaptive, well, how quickly and effectively companies adopt and integrate these wireless technologies, that's really going to shape their competitiveness long term. If you're interested in digging deeper into this whole transformation, we absolutely recommend checking out the full analysis. It's titled Wireless Connectivity, Enabling the Next Industrial Revolution, prepared by the Alpert research team. You can find their presentation on the future of the wireless industrial revolution at the link provided in our show notes.